Hello, I'm Tony Coe, the host of TalkIT Global. Today, we're connecting the aha moments shared by the winners of the 2025 Queen Elizabeth Prize for Engineering. Moments that shaped the birth of modern AI. First, Geoffrey Hinton, the godfather of AI. His aha moment came in 1984 when he built a small language model that learned the meaning of words through backpropagation, introducing the fundamental principle behind today's LLMs for the first time. Next is Professor Fei-Fei. In 2006, she realized that the reason machines couldn't generalize wasn't the algorithm, it was the lack of data. So she spent 3 years building ImageNet, transforming the entire history of machine learning. And the person who amplified both of these breakthroughs into reality was NVIDIA's Jensen Huang. In 2010, he discovered that deep learning software, like chip design, followed a pattern of infinite scaling. He saw earlier than anyone else the GPU will become the accelerator of the AI revolution. In the end, don't you think these 3 decades of aha moments from 3 pioneers came together to give birth to today's AI era?
In about 1984, I tried using backpropagation to learn the next word in a sequence of words. So it was a tiny language model, and discovered it would learn interesting features for the meanings of words. So just giving it a string of symbols, just by trying to predict the next word in a string of symbols, it could learn how to convert words into sets of features that captured the meaning of the word, and have interactions between those features, predict the features of the next word. So that was actually a tiny language model from late 1984, that I think of as a precursor for these big language models. The basic principles were the same, it was just tiny.
But
we had 100 training
years.
examples.
It took 40 years to get us here, though.
And it took 40 years to get here, and the reason it took 40 years was we didn't have the compute and we didn't have the data. And we didn't know that at the time. We couldn't understand why we weren't just solving everything with backpropagation.
Around 2006 and 2007, I was transitioning from a graduate student to a young assistant professor, and I was among the first generation of machine learning graduate students, reading papers from Huang, Joshua, Jeff, and I was really obsessed in trying to solve the problem of visual recognition, which is the ability for machines to see meaning in objects, in everyday pictures. And we were struggling with this problem in machine learning called generalizability, which is after learning from certain number of examples, can we recognize something, a new example, a new sample? And I've tried every single algorithm under the sun, from BaseNet to support vector machines to neural network. And the missing piece that my student and I realized is that data is missing. You know, if you look at the evolution or development of intelligent animals like humans, we were inundated with data in the early years of development, but our machines were starved with data. So we decided to do something crazy at that time to create an internet-scale data set over the course of 3 years called ImageNet that included 15 million images hand-curated by people around the world across 22,000 categories. So for me, the aha moment at that point is big data drives machine learning.
Ironically, in 2012, Geoffrey Hinton's student won the ImageNet competition by a landslide with a deep learning model called AlexNet. And they used NVIDIA GPUs, lighting the fuse for GPU-based AI research.
Around the 2010 timeframe, simultaneously from 3 different labs, what was going on in University of Toronto, researchers reached out to us at the same time that researchers at the NYU reached out to us, as well as in Stanford reached out to us at the same time. And I saw the early indications of what turned out to have been deep learning around the same time, using a framework and a structured design to create software. And that software turned out to have been incredibly effective. And that second observation seeing, again, using frameworks, higher level representations, structured types of structures like the deep learning networks, was able to develop software was very similar to designing chips for me. And the patterns were very similar. And I realized at that time maybe we could develop software and capabilities that scale very nicely as we've scaled chip design over the years. And so that was quite a moment for me.
Lastly, your likes and subscriptions greatly empower us to continue creating content. Thank you for your support.